Welcome to your college algebra review for Module 1. So this is our first exam. You got 10 questions laid out for you. Again, we're testing you over sections 1.2, 1.6, 2.1, 2.2, 2.4, 2.5. So let's go ahead and get this started by taking a look at our first few questions. And as we go through these questions, I will tell you where they're coming from. Here we go. Question number 1. So we're going to solve the equation by completing the square. All right. So remember, complete the square. When we start going through this, what's the first thing you need to double check? You had 2 pre-flight checks to do. 2 things to make sure that this happened before you complete the square. What were they?
The number next to x is 1.
Which x?
Squared.
The x squared part. So if we look right here, our number in front of x squared is 1, so that's a good thing. So that's a part of our first check, so that's okay. And then what else do we got to do?
Do we move the 5 over to the right?
Yes. We're going to isolate these 2 variables. Yep. So this -5, how do I move it to the other side?
Add it.
All right. So what we're really looking at is x squared minus or plus 6x equal to 5. Now we're ready to complete the square. So what's the first thing we do for complete the square?
We find c.
We got to find that c because we want to make this piece right here, this x squared plus 6x, factorable, and that's what complete the square helps us do. It makes this factorable. So we got to find that new c value because we moved the 5 away. What was the formula for c?
It's b, which is in this case 6 divided by 2 squared, which in this case that would be 9.
All right. So yeah, you are correct. Doing a lot of that in our head. Remember, I always show a little bit of work in this, but you are correct. To find c, it's b divided by 2, and we're going to square it. You told me b was what again? 9. No. What was b? 6. So you plug that 6 in there, and we're going to square it, and 6 divided by 2 is the 3, and when you square it, that's the 9 that Brandon gave us. Perfect. I love it. And I showed this little intermediate work right here because later on we're going to use that guy. Yep. Okay? So now we move on to step 2. What do we do with this new c?
Basically, we added both sides.
You got it. We're going to take that red equation up there and we're going to add 9 to both sides. So we have x squared
plus 6x plus 9 equals 14.
And I like that you said 14 on the other side, but I'm going to show that's 14 in the next step, but I will put the plus 9 there. Because again, this second step, all I wanted to do was force my 9 into the equation, and what I do to one side, I got to do it to the other. So since I added it to one side, I had to add it to the other. And now we are ready to finish the complete the square part. Okay? So this is where making this new c value and putting it over here, this piece right here is now factorable. And I like what Brandon said a moment ago. He took these 2 numbers and put them together, which is 14. I agree with that. But we got to talk about this side right here, and this is factorable. And in class, remember that I gave you the fast way to get through this. If you can't remember that, then just factor this like normal, okay? But it does factor to parenthesis. There's an x inside, and your parenthesis is squared. Plus 3, because this is where that green box that I had right up here, this number that's right there, this is what's going to get plugged in there. And since it is positive, that's why Brandon said plus 3. If that was a negative number, we would have said minus 3. Okay? So there it is. So that's how this piece works. This part right here always factors into... Say it again? Nope. Because if it was a minus 3 in here, that would make this a negative 6.
Right, we're using the number before.
Correct. So remember that this guy right here always factors just like this. There's parentheses, parentheses, it's squared. You got your x, and then you just got to figure out what this number is, and that's the number right there before we squared it. So once you take the b divided by 2, that's the number that gets put in right here. And so that right there completes the square. It's all done. All we need to do now is get x by itself for the answer that we're going to look for.
So square root both sides.
That's right. So we're going to square root both sides because that's how we get rid of something squared. So the square root and the square take care of each other, leaving us with?
X plus 3.
Now what's the other side equal to?
Square root of 14.
Nope. This is a piece that my algebra students always forget.
We gotta do the thing where we try to break down the...
Not yet?
Let's see. We have the step now. Square root both sides. Oh yeah, plus minus 14.
Plus and minus. There we go. Plus and minus the square root of 14. When you square root both sides of an equation, you slap plus or minus into it. Now, I like what you were going with there next, Brandon. You always need to check this radical and see if it can break down any. So that's where you separate it out into two radicals. One is a perfect square and break it down from there. I call that good child, bad child, but that's just me. So the question is, can the square root of 14 break down?
Well, not in the traditional square root sense, but let's see. 7 and 2 go into it, but 7 and 2 don't break down to anything else, so I don't think you can.
Correct. 7 and 2 are two numbers that make 14, but 7 and 2 are not perfect squares. Because remember, perfect squares are a number times itself. So 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. Okay? So this stays. So then that means we only have one more step. What now?
Subtract 3.
That's right. Move this number away from x, and you're either going to add or subtract it away. So we subtract 3. We now know what x equals. I always write this number before your square root. So x is equal to negative 3 plus or minus square root of 14. So all we have to do is go up and look at our multiple choice and find an answer that has that in it. So the only answer that has a negative 3 plus or minus the square root of 14 is A. And that's to complete the square. Moving on to the next one. Number 2. Use the quadratic formula to solve. So if you forgot the quadratic formula, it looks like this.
It's negative b plus or minus square root. Oh god, I hate this one so much. It's a lot of work.
B squared minus 4ac all over 2a. So all we have to do is plug in our values, A, B, and C. But I don't plug into this whole thing right away. I make my students go through this part first. Remember, that's called the discriminant, because in college algebra, we care that the discriminant is 0 and above. As long as the discriminant is 0 and above, we can solve. If this number right here ends up being negative, then we select this choice right here where it says there are no real solutions. So if this guy is right here is negative, we're done with the problem. So that's why I always start with the discriminant first, the b squared minus 4ac. So if we look up here, what is the value of a?
X, so I guess 1 in this case?
It's the number in front of x squared, which is 1. So that's your a. What's your b?
B is 2.
Negative 2. We include the sign. What's your c?
That would be a negative 12.
There you go. So let's take these values and we're going to plug into b squared minus 4ac. So who is b?
Negative 2.
So we're going to take negative 2 and square it, and minus 4. Who is a?
1.
And who is c?
Negative 12.
Okay. So when I run this, I work the squared part first. So what is negative 2 squared? Say it again, Brandon.
That's 4.
Perfect.
Minus.
Minus. And then now I work the multiplication.
4 times 1 is just 4, and then 4 times negative 12 is negative 48.
So I got negative 48. That's the second part. And then the third part is where I actually do the subtraction of the two numbers.
And since it's a negative subtracting, it's basically just a positive, so that's 52.
Perfect. So since our discriminant is positive, we keep going. The answer cannot be choice B. So now we're going to work choice A. We're going to get the answer running the rest of the quadratic formula.
Square root 52.
So x equals, we first need the opposite of B. What's the opposite of our B?
2.
So positive 2, because our B was originally a negative 2. Plus or minus, we already know this number, 52. That's our discriminant.
Over
All over 2 times, what was our A?
a 1, so it's,
Which is just 2. All right. So this is what we're looking at now. If you do the multiplication on the bottom real quick. All right. So before you finish, though, we need to do some simplifying. The first thing you're going to check out is your radical. So can the square root of 52 break down? Is there a perfect square that divides it?
4 divides it. I know that.
Okay, so definitely 4. But the question is there anything bigger than the 4?
4, 9, 16. Let me just double check 16.
So checking 16, that would be a good one to check. 52 divided by 16? Nope. Okay.
Got that. So I don't think anything goes into that. Wait, 36. Oh wait, no, not 36. No.
Try 36, just make sure. Okay.
36, so nope.
Nope.
Yeah, I'm pretty sure the biggest number is 4.
All right, so we need to take this square root of 52, and we're going to separate it into the square root of 4 times what?
52 divided by 4 is 13.
Okay. Sign in. Grab a piece of paper. All right, so what's the square root of 4?
2.
2. Square root of 13 stays. So this number is going to come over here and replace that. So what we have now is x equals, scroll back up a little bit, 2 plus or minus 2 square roots of 13 all over 2. So we've taken care of the radical. Now you're going to look at this part. Those 3 numbers.
They all divide into each other.
They all divide into each other, right? There's a number that can divide all 3 of them. And so we take that number, we divide them all by that number. So all these can be divided by 2. So our final answer is, and since the denominator becomes 1, we're going to ignore it. So 2 divided by 2 is 1. Plus or minus. 2 divided by 2 is 1. Square root of 13. Again, the denominator is 1, so you can ignore it. So this is the end-all, be-all answer. All right. So then we go back up top, and we look for that answer. Well, actually, no, we got to put that answer in. So also now, make sure that you watch out for the little blue information that's down below. So it says type an exact answer, which means using the radicals. So we got that. And it says use commas to separate your answer. So we need to take this answer that we have down here, and we need to separate it out into its 2 pieces. One of them will be the plus version. One of them will be the minus version. And it doesn't matter which order we have. So who do we want to write first?
1.
Okay, so 1
Plus
1
square root of 13.
square root of 13. There we go. And then we'll put a comma, and we'll write the next answer, which is 1 minus 1 square root of 13. And that's what they want. Grab a worksheet, sign in. All right, well then don't stay. Yep. Yeah, that'll be what you fill out after we're done. Okay? Make sense? Yes. Good, I'm glad you agree. All right, next question. So question 3, we want to solve the absolute value inequality. And then down below that, it says graph. Now up here it says there are like 3 different possible solutions. One says that there are finitely many solutions. One says there are infinitely many solutions. And then no real solutions that we got to worry about.
I know from the homework that's very much almost always infinitely many solutions.
Correct. When we're dealing with these, because we are talking about real numbers, it's not going to be finitely many solutions. Finite means that there's a beginning and there's an end. Here's where it starts, here's where it ends. Okay? And there's like solid, it's like solid numbers. It can only be these numbers. Like for instance, if we solved this and the answer was 2 and 7, that's a finite answer. Those are the only 2 answers that work. There's no one else. It is 2 and 7. But because we're dealing with inequalities, these things have infinite amount of answers.
And then you can just add a decimal.
Correct, because you can always add a decimal and you can always add 0 to a decimal to make it an entirely new number within that range. So all these answers are actually going to only be contained between B and C. We either have infinitely many solutions, and this is the set, or we have no real solutions. The finite is thrown out because we are in the real number system. All right. Now, so the first things first, when we deal with absolute value, what has to happen before we can do anything?
Put that 0 on the other side.
That's right. We got a pre-flight check. We need this by itself. So we got to take the +2, move it to the other side. How do we do that?
Subtract in this case.
-2, -2. So we have the absolute value of x minus 8 less than 3. This is what we're going to work with from here on out. This is the problem that is going to tell us if we are an and or an or. Which one do we have? Because absolute value inequalities are all about compound inequalities. Is this an and or is this an or? How'd you know it was an and? Because it's less than. And remember, I kind of made that mnemonic device in class. Whenever you have this, think about it as less than. If it was a greater than, think about it as great or. Okay? So all greater than symbols are ors because it's great or. All less than are less thans as an and. All right. Absolute values have how many answers? 2. Now, since we're talking about ands, I can kind of look at the second question right here for you. And there's only a couple pictures that are going to work for us. Because and shade where? Together. In the middle. Okay? There's only a couple graphs up here that have in the middle. Who is that? A and B. Okay? So, this graph is gone. This graph is gone. This graph is gone. For sure. Now, it could be one of these other ones. Okay? Maybe it's a dot, maybe it's not.
Did you say no dots in this one?
So, there we go. Now we're starting to think. Okay?
The bottom one's just blank.
Well, the bottom one is blank, but we don't know if this is a no solution yet.
Oh, yeah.
So if you have a no solution, that's what the H is for. Okay? But if it does have a solution, then we're probably looking at either A or B. So see, right away, we can throw out 5 out of those 8 graphs just by knowing that this thing is naturally an and shade in the middle. All right. So now, we're going to take this guy right here, and we're going to write our 2 equations. Excuse me, 2 inequalities. The first inequality is always the one that I get and you guys are always really good at. How do we make the first one?
X minus 8 is less than 3.
There you go. You just drop the absolute value and solve. So you have x minus 8 less than 3. So how do we solve?
We add 8 both sides.
Plus 8 plus 8. X is less than 11. Perfect. Now, to get the second equation, what do we do? Okay. So what do we do with the absolute value, though?
Keep it the same.
So you keep it the same. You drop it. So we drop the absolute value. So that gives us x minus 8. And then, Samantha, I like what you said. We flip the inequality so it becomes a greater than.
And then we do the opposite.
Then you give me, yes, the opposite of that value 3. What's the opposite of a 3? A negative 3.
And then we add
So,
both sides
yep. And then we're going to add 8 to both sides. But just to recap again, when you're doing the second equation, second inequality, drop, flip, opposite. You got to do those 3 things. Drop the absolute value, flip the inequality sign, opposite of whatever's going on the right side. Drop, flip, opposite. So, x is greater than what? 5. Now we know the 2 numbers that our graph should be contained to. So we're going to scroll back up and look for a graph that deals with 5 and 11. So which graph has 5 and 11? A. They both do. The difference is one's a parenthesis, one is a bracket. So let's go back down here. Which one am I going to choose, the parenthesis or the bracket?
Parentheses, it's not a greater than or equal to.
You're not equal to. There you go. You look at your little symbols right here. There is no equal to, so they are parentheses. If it had the line underneath it that meant equal to, that would have been the bracket. Okay? So if I go back up here, we now know that the graph has to be A.
Sorry, can you go back really quick?
Yep.
How did you get the solution turned around? I mean, yeah.
It flips from the very beginning when we write the second one. You drop the absolute value. The less than sign has to flip. And then you take the opposite. It's drop, flip, opposite. You have to do those 3 things. Drop, flip, opposite. All right. Now, the only thing that we have left to do is, because we know that this is an infinitely many solution, there are infinite amount of solutions in here, even though it looks like it's closed off. There are infinite amount of answers in there. We just need to write up the solution set. So, it's a set, or actually no, it says write your answer in interval notations. So I don't know why they said interval set up here, because that's just an oxymoron. It's not a set, it's an interval notation. So what would the interval notation to this look like? So that's important. Make sure that you read those little directions down here. It's not a set they want the interval. So what's the interval for that?
I think I have it, but I don't know which one it is.
Well, tell me what you got, Samantha.
Interval's the one in the.
I have the 1 and 5 and 11.
Say it again.
5 and 11.
5 and 11. It's a little bit more than that. What else are we going to have?
I have it here. I just don't know which one. Which to call which one. I don't know.
Well, if you have braces, that's what we call a set. But it's really after interval notation, which would not be in a set. That's just weird. You'd really do one or the other. So it's kind of weird of them asking this question like this.
What's the sign? So it's parentheses 5, comma 11.
There you go. Comma 11, parenthesis. So you take the parentheses that you had here, you slap the number down, put the comma between the other number, and then end with a parenthesis because, again, your interval notation should match what you have down here. So there's our and answer.
So this isn't correct?
What you gave me there is the set. If you read the blueprint right here, it says interval. And we don't really put interval notation inside a set. That's weird. That's bad formatting. Okay, so that's just my math lab being my math lab sometimes. Okay? Computer. Any questions about this one so far? Okay? Make sure you read that blueprint. Okay? Because that's going to tell you how to format your answer. Where do you want me to go infinite?
Go back up to the part where I just said before. I want to see the fifth dot and flip to.
Nope, this is normal.
Okay, so that one.
The original one, when you make the first inequality, all you do is drop the absolute value. When you make the second, drop, flip, opposite. Always. All right. Question 4Z's. Is our absolute value by itself? Yes. So it's ready to go. But before we do this, is this going to be an or an and? This is an or because that is great or. So this is an or problem. So how do or shade? On the sides, right? So right away we can throw out two of these kind of graphs.
Wouldn't it be three?
Maybe.
It's just one big line.
So who can we throw out? No, you can't throw out A. That's an or graph. Well, don't worry about parentheses and all this stuff. So who can we throw out? No, we got to keep B. Could be infinite. So you can definitely throw out E. That's an and graph. You can definitely throw out D. That's an and graph. This is an or. Okay? And F and H. Because we should end up with infinitely many answers, not finitely. Okay? Everybody else has to stay. Does that make sense? So when you're looking at your graphs, if it's an or, throw out all the graphs that are ands. Get rid of them. Because they don't work. All right, so let's talk about our equations. So you said this absolute value is by itself. What's the first equation going to look like?
4x minus 9 greater than or equal to 2.
You got it. And I keep saying equation. I meant inequality. No, you were right. Just drop the sign. 4x minus 9 greater than or equal to, what was that value? 2. Just drop. The first inequality looks just like the statement without the absolute values. All right, what's the second one going to look like now?
4x minus 9 equal to or less than negative 2.
There you go. Because we dropped, we flipped, and we took the opposite. Okay? All right, so let's solve. How do I start solving for x here?
Add 9 to both sides.
Okay. Plus 9. So 4x greater than or equal to, what's 9 plus 2?
11.
11. Now what do we do?
Divide both sides by 4.
Okay, divide by 4, divide by 4. X is greater than or equal to what? 11 over 4, because you got to leave it like that. No decimals. It wants exact answers. Any questions over that one? Cool thing again, just like what you kind of saw in the previous problem, since these are absolute values, whatever methods we use to solve the first one, same methods we're going to use to solve the next one. So we added 9 over here in the first one, we will be adding 9 in the other one. We divided by 4 over here, so we will divide by 4 over here in the second one. The only thing that's changed is your value right here is now a negative number. So that's the only difference. So again, we'll add 9. 4x less than or equal to, what's negative 2 plus 9? 7. And then what? Divide by 4, just like last time. So what is 7 divided by 4? 7 over 4. Okay. So let's go up. All right. Which picture matches what we know below? It has to be C. Why is it C? How did you know that one versus what was A? Say it again. And you guys chose the bracket. Why? Because we're equal to. Our symbols are equal to. Those are brackets. Good. So that's why the graph has to be C. Now, up here, who would you select? A, B, or C? You'd select B. Good. When it says to do set. So when you look at this, here's the directions. Are we doing set or interval notation?
No, I mean like in the math lab thing, I remember when I was doing this for the homework, it was A, like answering set, or B, answering interval. Could I just pick which one I wanted?
No. It shouldn't have done one in set and one in interval. Below each one of these, it should say the information you need. Okay? So here, this is actually written up correctly. Notice there are no braces here. So maybe someone just copied that other problem wrong, because there shouldn't have been braces. So you can see that we're doing it in what? So make sure that you read this fine print. It tells you what to do. Okay? Read the fine print. That's how you know when you will do set versus interval. Because if they want set, it should probably say something about being set under here. Okay? So we need interval. So our graph was C, that was down here. So we need to write this as an interval. So start down here at the left-hand side and work your way across.
So negative infinity.
So it starts at negative infinity because this arrow is filled in, right? Negative infinity, bracket or parenthesis?
Parenthesis, I believe.
That's right. Infinities always get parentheses. Okay? And we go up to what?
7/4.
7/4. Okay? Because that's our lowest number. 7/4. Bracket or parenthesis?
Bracket.
Bracket. Because it matches your graph, right? Yeah, we've got a bracket. Now what?
Comma.
Nope. Good, infinite. It's a union symbol. Now, please, 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 when you do this symbol, use the MyMathLab symbol. Do not put a capital U in. It will mark it wrong. So if you are missing some of these when doing the interval notation, it's probably because you put a capital U in. You need to use the MyMathLab symbol for U. And so you just check along the little options that they give you, and that union symbol should be in there. All right. What do we put down next? Whoops.
Bracket.
Bracket. Then what?
11/4.
11/4.
Comma infinity.
Comma infinity and
Sign.
parenthesis. There it is. That's the interval notation. And that's what OR interval notation looks like. You should have a union. Questions? Okie dokie, artichokes. Here we go. Let's go to the next guy. Question 5. You're running distance. All we got to do is run the formula. That's it. And make sure that we reduce your answer. They want it exact. So that means no decimals on this. What is the distance formula? D equals, yep, square root.
X1 minus x2 squared
Yep.
plus y1 minus y2 squared.
There we go. All you got to do is plug in. So take the 2.5 seconds here. They even tell you who P1 and P2 are. So in here, here's P1. So these are X what, Y what?
X1 and y1.
X1, Y1. Take the 2.5 seconds to write that stuff out. Oops, I put a 2 there. That should have been a 1. So this is P2. So this is X what, Y what?
X2 and y2.
You got it. All you got to do now is take those numbers, plug them in where they go, kick out the distance. Okay? So D equals square root, parenthesis, who's x1? 4. Minus, who's x2? 1. Squared, plus, who's y1? Negative 3, who's y2? There you go. All right, so we filled in. Now we just start doing some PEMDAS. PEMDAS says take care of your parentheses first. So what's 4 minus 1? Plus, what's a negative 3 minus 3? Negative, stop it, 6. Okay? Any questions so far? So now you take care of the squaring. After you do this step, there should be no negative numbers left. Once you do this step right here, and we square, there are no more negative numbers, because distance always works out to be a positive number, no matter what. So what's 3 squared? 9. Plus, what's negative 6 squared?
36.
Positive 36. No matter what that calculator tells you, it is a positive number. And then 9 plus 36? 45. So this is where you need to look at this number and figure out if it simplifies out. Is there a perfect square that will divide 45? 9. Is that the biggest?
Yeah.
Okay. So we have the square root of 9. What times 9 gives me 45?
5.
So what's the square root of 9? Square root of 5 stays. That's the answer they're looking for. That's the answer they want. Again, as you're working this formula, I've seen a lot of students, when they run this formula, they put the square root in it at the beginning, and then all of a sudden they start dropping it as they go through. Do not drop the square root until you get to the very end, and only drop it if this is a perfect square. Because the square root of 4 becomes the number 2. There's no more radical. Okay, that's the only time that square root would disappear, is if you have a perfect square down there. Other than that, that radical stays. So again, the answer they want up there is 3 square roots of 5. Yeah, you got till the end of class to get it done. How many questions are on this? Nope. 10.
That's it?
Yeah.
That's a lot.
Yeah, you got 2. Okay? All right. This guy says midpoint. Just run the midpoint formula. So what is the midpoint formula?
x1 plus x2 divided by 2 and y1 plus y2 divided by 2.
There you go. So in other words, add the x's, divide by 2. Add the y's, divide by 2. And write your answer as a point. See, look right here. It's even reminding you. This is an ordered pair. In the end, it is a point. And again, just take the 2.5 seconds. This is x1, y1, because it's all part of point 1. This is your x2, y2, because it's all part of point 2. Always remember that x comes first, then the y value. All right. So, who's x1? Plus, who's x2? Who's y1? Minus 0. Now, when you do this, just like what you did in your assignment, they want exact answers. They do not want decimals. If they wanted decimals, they would say that up there, that you could have decimals. It just says simplify your answer, which means that if it doesn't simplify all the way down, you leave it as a fraction. So in other words, if you get an odd number in the numerator, slap it over 2. because it will not divide out. And they do not want mixed. So as we work through this, what's negative 3 plus 10? Oh, it's odd, so what's the answer? 7 over 2. Leave it. What's 2 minus 0? 2. And 2 divided by 2? 1. So since that numerator was even, you went ahead and did the division. There's the answer. Make sure you put the parentheses in your answer because it is an ordered pair. That means point. So parenthesis 7 over 2, comma 1, parenthesis. That's what they want. Yep. Formula again. Add the x's, divide by 2. Oh, I don't know why I put subtraction there. Still didn't change the answer, though, because it was 0. But yeah, oh, that should have been a subtraction. So good. Thank you for catching that, Samantha. Yep, it should have been a plus. I might have said plus. I can't remember. I probably did say minus, so that's all right. But anyway, 2 plus 0 is still 2. 2 divided by 2 is still 1. So we're okay on that. Good catch. Yeah, absolutely. Add the x's, divide by 2. Add the y's, divide by 2. All right, question number 7. And this looks like a typo. This guy right here should not be x squared. It should be a y squared. Okay? So, can we use our calculator on this?
Not yet.
Not yet. I haven't taught you how to do that. So this is where, when we do this stuff, we actually have to work this out by hand. Calculator ain't going to help you on this one. Okay? So let's talk about intercepts. And how are we going to write this answer up? Am I just going to give numbers or am I going to give points? Points. Because again, it says ordered pairs. All right, so let's talk about how we do this. How do we find x-intercepts?
0.
Plug in 0 for y. Good. And we're going to solve for x. So we're going to have 0 squared equal x, was it minus 64? Nope, plus 64. So, how do we solve for x? Yeah, we're going to subtract 64 to the other side, right? What is 0 squared real quick? Yeah. So in the end, when we subtract 64, we get x equal to what? So what is that as a point again? Negative 64, comma, 0, in parentheses. That's your x-intercept.
It's not plus or minus. It's the x.
Did we square root both sides? Then no plus or minus. You only throw plus or minus if you square root both sides. Square root both sides. All I did was square 0. What's 0 times 0? 0. Okay? How do we find y-intercept? But we do x, right? So similar process, but instead of plugging into y with a 0, we're going to plug into x with a 0. So we have y squared equal to 0 plus 64. So what do we do now? Can't square root yet. We got to take out the 0 part, right? What's 0 plus 64? 64. Now we can do your square root, because how do we get rid of something squared? Square root, square root. Y equals what?
8.
Good, Samantha. Say that again. Plus or minus 8. Because when you square root both sides, you slap plus or minus in front of the number. It's the second time you've seen this on this quiz. Or excuse me, test. Because the first one was when we did complete the square. So what are my answers then for the y-intercepts?
0, negative 8, and 0, comma 8.
There you go. 0, comma negative 8 and 0, comma 8.
You know if it wants in a specific order? Because I know...
Nope. Shouldn't. It just says...
I meant on the when you do it on the website.
Shouldn't. It just says, give me the intercepts. And you put commas between those answers.
As long as it has all the commas.
Yep.
Sometimes
So
it's
negative 64, comma 0, comma 0, comma 8, comma 0, comma negative 8. Don't put any spaces in there. Just put commas. That's the space. Okay?
So we'll accept that on the website in any order?
Any order.
Okay.
Okay? If it wanted order, it would have to specify for you. Otherwise, that's just plain mean.
Then you'd just be redoing the question.
Well, yeah, I mean, then you'd be guessing, what do they want? No, they just want it as points. There they are. Now, we got a test for symmetry. Because again, we can't look at our calculator. I haven't taught you how to put those in. Okay? So, how do we test x-axis?
Swap the y values.
Swap the y value for what?
Negative y value.
Okay. So we're going to plug in a negative y and see if we get the original equation back out. All right. So let's come down here and do that. So remember, our equation was y squared equal to x plus 64. So to test x-axis, we're going to plug in the negative y. And since I was plugging into a power, I put parentheses around it. Remember, I talked about that in class, that anytime I plug into a power, I put it in parentheses. Anytime I plug into a power, I put it in parentheses. All right, so we do as much simplification as we can. Can I take this negative y and square it?
Yes.
Yeah. What is negative y times negative y? Y squared. Equal to?
X plus 64.
X plus 64. Okay. Does this match that?
Yes.
So what's that tell us?
Symmetrical on the x-axis.
All right, so we can come up here and we can answer for part B, yes. Because it was the same equation. Okay? How do I test y-axis? Plug in negative x. Good. Okay? So we'll come down here. Y-axis. Plug in a negative x. So I got y squared equals negative x plus 64. Okay? I'd now do any simplifying that I can. Is there any simplifying? No, you can leave it like this. Some people will choose to make the x positive and divide everybody by a -1, but it still doesn't change the answer. Okay? So some of you will come out here and divide by -1. Remember, everybody will get divided by it. And that will give you negative y squared equal to x minus 64. Now, I do not put this negative y in parentheses because they are not originally together. I brought this negative to the party instead of doing what we did over here where we plugged into it. There's a difference between plugging in and bringing a negative over to the party. So, the question again, whether you divide by -1 or not, is this equation, or this one down here, the same as that? Nope. So what's that tell us about y-axis?
Not symmetrical.
Not symmetrical to it, because they are not the same. So we come up here, and we say no. How do we test origin? Negative x and negative y. And the negative y. All right, so we'll come down here. And move that circle out of there. So now we're going to look at origin. So, Because it's a negative y, I'm going to put it in parentheses because it has that power on it. Over here, I don't have to put the negative x in parentheses because it's not powered. So now, again, we do any simplification that we can. Start with your powers, then worry about everything else. So the negative y, can I square it? Say it again. Becomes y squared, because the negative y times the negative y gives you y squared. Equal to, still that negative x plus 64. Is there any other simplifying that we can do? No, you can leave it like that. I mean, if you really wanted to, you could divide by the negative 1 again. And you get right back to this guy that's right here.
Why would I not want to just think of it as there's no square on the x, so therefore it's not going to be the same?
Well, depending on what it might have happened over here, it might have been the same. You got to look at it from both sides. Okay? Yeah, good question. So if you wanted to divide everybody by negative 1, you can, but you can just leave it like this. So finally, this equation and that one that's right there that I'm going to scroll up to, do they match? No. No. So what's that tell us about origin? Not symmetrical. There you go. So that's how this problem will play out in the end. So your intercepts listed right there as points. And then you have yes, no, no for the test for symmetry. Any questions on that one? Okay. So, question number 8. Here's our circle. So the first thing says, find the center.
H and K, which is -3, 2.
Yeah, hopefully you got that. You look at the circle, it is the middle dot. So -3, 2. There's the center. How do you find the radius?
Count how many spaces it takes to get the center from one side.
There you go. Start from the center, work straight to a side. You can either work your way up, or you can work your way down from the center, or to the right, or to the left. It doesn't matter because all those will be the same distance. So let's just work this direction right there. How many lines is that? 2. Now you know the radius. So what's the radius again? 2. Okay. Notice that up here, I wrote the center as an ordered pair. Ordered pair just means a point. And now all you got to do, just like what we did in class, is write the equation. Although, Brandon, you haven't experienced this yet. But my other 3 have. What's the equation of this going to look like?
X plus 3.
Okay. So you got a parenthesis, x plus 3. Parenthesis squared plus parenthesis y minus 2 equals 4. Good. There you go. Because the standard form of the equation looks like x minus h squared plus y minus k squared equal to 4. Sorry, not 4. That's just silly. Equals to your r squared. So all we did was plug in the h and the k and the r from what we had earlier into the equation. Or like I said in class, when you look at this, your center is the opposite sign in the equation. So that's why we got the x plus 3, because a -3 becomes a plus 3. That's why we got the -2, because a positive 2 became a -2. And then the 4 came from taking the radius and squaring it. And that's it. There's our equation. All right, 2 more questions left, and they are your word problems, which we're getting there. Just we haven't experienced that yet, and that's okay. We're going to talk about it right now, and I'm going to walk you through it. So, as I told you in class, these are 3 steps. The first step is to write the initial equation. So, we care about this word directly, right? What did I tell you about directly in class? So, everything that is before that word is a variable in front of the equal sign. Everything after that word or box is a variable after the k, right beside it, because it's multiplication. So what variable do we have in front of the box? S. So I've got S equals k. What variables do I have after? T. But you need to make sure that you read carefully, because there is something about this t. It says that it is the square of the time. So what does t really look like? T squared. So you got to do a little bit of translating sometimes. And there you go. There's our, what we call the initial equation. Okay? Now, step 2 wants us to find out what k is. So that's where these first 2 numbers are going to come involved. One of those numbers is your S. The other one is your T. And we're going to plug those in and figure out what k is for our equation. So the 16, that's your S. That's your distance. Equal to k. What's your T? 1, because that's in seconds. That only makes sense that the 1 goes in for time. So now we want to solve for k. So the first thing we're going to do is take the 1 and square it. What's 1 squared? 1. Cool. So 16 equals k times 1. How to get rid of the multiplication of 1? Divide by it. So we're going to divide both sides by 1. So k is equal to, now we rewrite our equation with only the k value. So we have what equation? 16t squared. Good. Okay? But we're not done, because this is where we dive into step 3, because this is a context problem. So in here, they actually start to give us some extra information. This is where our 2 questions come from. In question A, they tell us that this thing has fallen for seconds. They want us to find out how far it fell. Does that make sense? So we're finding S. They have given us T. So we're going to plug in. S equals 16 4 squared. So what's 4 squared? 16. So we want to know, what is 16 times 16? 256. Okay. And is that feet or seconds? That's really what the second blank is for. Say it again. Feet. So 256 feet. That's why you see this part right there, because it's asking you, is it feet or seconds, the label. Okay? So in 4 seconds, that object fell 256 feet. It is a lot. All right. Now we do the second question.
This one we have the S, I believe.
So this one, they've given you 144 feet. That's S. So this time we're solving for time. So 144 equals 16t squared. What are we going to do first? All right. So we got to divide both sides by 16. So what is 144 divided by 16? Okay, you can do that. But you need to make sure that you square root both numbers, and do not forget plus or minus. Okay? You want to isolate your square part, and then your square rooting should be the last thing that you do. So what is 144 divided by 16? 9. So we got 9 equal to t squared. How do you get rid of something squared? Square root. This is where we do the square rooting. So t is equal to what? plus or minus 3. Now let's talk about this answer. This is time, right? So it's just a positive version that we want. Because you can't have negative time. We haven't invented time travel yet, so negative time does not exist. So in this version, we don't care about the negative 3. We only care about the positive 3. So here in our answer, we have 3. Is that feet or seconds? Seconds. Okay? So that's this problem. That's how it works.
That's not bad.
Yeah, not bad, right? Let's do one more.
I mean, there is only one more.
That's right. So here it says the volume of gas, V, held at a constant temperature in a closed container varies inversely with its pressure. All right. What's our main word here? Inversely. What does inversely mean? Divide. So this looks like equals K with a line under it. Anybody before the box goes in front of the equal sign. Anybody after the box goes under the K because it's division. So what does the initial equation look like?
V equals
K over what? P. Good. So there's that. All we have to do now is continue on with the process. So the next two numbers they give us, we're going to plug in and find out what K is. Okay? So we're going to take this 600 and we're going to plug it in. And we're going to take the 150 and plug it in. So the question is, who does the 600 go for? P or V? V, because it says volume of gas. Okay? So V is 600 equal to K over, that means the 150 must be the P. And it makes sense because it says pressure is. So how do we solve for K? Multiply by 150. Yes, this is going to be a big number. That's okay. So K equals what? 90,000? Is that good? So our original equation up here is V equals 90,000 over P. That's step 2. That's the end of it. All we got to do now is we're going to apply that formula to the new information. Okay? So we want to know when the pressure is 200 mmHg, 200 milligrams of mercury, they want to know what the volume is. So who is the 200 milligrams of mercury going in for? It's going in for P. You got it. Sounded like you said B. So, scroll down just a little bit. So, V equals 90,000 divided by 200. $90,000 divided by 200. 450? Okay. Now the question is, what is the label for it? Centimeters cubed, right? And that's A, B, C, or D? C. If you ever get confused on your label, go right back up into the problem. Look at the label for the volume. Here's volume. Cubic centimeters, which is cc. That tells you the label right there. And that's it. That's what your test is going to be like.